Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Incantation by Gerhard 1963. And here are the rules. Standard Sudoku rules apply. The digits 1 through 9 appear in every row, column, and box. We also have quartet lines. I've never actually seen this rule set, so this is the same. Basically, I'm learning this as well as you. And these quartet lines are red lines may have no more than 4 different digits. Okay, so that you can only have up to 4 unique digits on a quartet line. So, for example, if you could have something like, I don't know, 3, 7, and 5, then you would have to have, you could not have something like 1, 2, 6, and 5 here, because that is already, how many? 1, 2, 3, 4, 5, 6 different digits on the line, and you can only have up to 4. So this would have to be changed to probably something like, I don't know. Yeah, I don't want to solve any more for this, so let's not do that. But basically, you can only have 4 unique digits on a quartet line. We also have crop key pairs, where digits in cells separated by a black dot are in a 2-to-1 ratio. Digits in cells separated by a white dot are consecutive. Not all dots are necessarily given. So, for example, if this were a 2, this would have to be a 1 or a 4 to maintain the 1-to-2 ratio. If this were, say, a 6, this would have to be 5 or 7 to make sure that these digits are consecutive. And that's how crop key pairs work. And finally, we have the final rule of digits in gray squares are even. So all of these squares are even. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so these digits are going to be the only 4 digits on this line. So we know, okay, so we're going to mark these. This is light, medium, dark, green. Similarly, these 4 are going to be the digits that are on this quartet line. So this is red, yellow, blue, and orange. Now we have a pink here, interestingly enough, and it's an even digit. But these digits are specifically made up of red, yellow, blue, and orange. So this is also a combination of red, yellow, blue, and orange. Right? Well, on this of these red, yellow, blue, and orange digits, we have 3 cells which must be in a 1-to-2 ratio with each other. And one cell is in a 1-to-2 ratio with 2 other digits. The only digit that can be in a 1-to-2 ratio with 2 other digits are 2 and 4. And that must be either with 1, 2, 4, and 8, or 1, 2, 4, and 8. So it's either 1, 2, 4 here, or it's 2, 4, 8. So this is either way, 2 and 4 have to be in these cells. Therefore, this cannot be 1, 2. This cannot be 2 or 4. It has to be 6 or 8 for the pink. This also has a 1-to-2 ratio for this quartet, right? So it cannot contain 2 or 4. It must be 3 and 6 in a 1-to-2 ratio here. So this is 3 and 6, which means this cannot be 6. This must be then 8. So this can't be 8. This has to be a 1-to-4 ratio. So this must be a 2, which makes that a 4. We don't know where that is a 4. This is a 1-to-2 ratio here. So 2 cannot be here. 2 is one of these 3 digits. This must be a 3-to-6 ratio. So this is 1, 4, 1, 2, and 4. This has 3 and 6. And we don't know where the 5, 7, or 9 is. Well, these two consecutive digits, one of them must be odd, the other must be even. Well, the only even digits in red, yellow, blue, and orange are 2 and 4. So one of these must be 2 or 4. The other has to be 1, 3, or 5 here. So this must, well, we don't even know. We know there's a 3 to 6 ratio. Of these digits, what is the odd even digit? We have 2 and 4 already here. 8 is here. The only even digit amongst this quartet is 6. And that has to be between two odd digits then. So this must be a 6 here, which means this cannot be 6. This must have 5 and 7 next to it. So this is 5 and 7, which means this quartet has to be 3, 6, 5, and 7. So this is also 3, 6. We know this is a 3 to 6 ratio. This has to be 5 or 7, and this could be 3 or 6, and this could be 3, 5, 6, or 7. Therefore, this must be 9 here. Well, 9 cannot be consecutive with the other digits. And the only consecutive digits in this set are 1 and 2. So this has to be 1 and 2 here. This must be 4 and 9. We don't need actually the coloring then, because the coloring is not going to help very much here. This has to be a 3 to 6 ratio. This cannot be 1, 2, or 4, and it can't be 6 because of this 3, 6 pair here. It can't be 1, 2, 4, or 9 because of the quartet set. These are the only two consecutive digits in this quartet. It's 1 and 2. So this is 1, 2. This 1, 2 pair eliminates 1 and 2 in the rest of the column. So this is 4. This is 1. This 4 eliminates 4 here. So this is 9. This is 4. Again, this cannot be 2 or 4. It can't be 6 because of the 1, 2, 4, 9 quadruplet in the box and the 6 in the row. So this must be 8. This is the only even digit remaining. So that's 6. This cannot be 6. This is a 1 to 2 ratio, and it can only be 3 and 6. So this is 3, 6. This is a 5, 7 pair. We have a 5, 7, 5, 7 pair in column 3, which eliminates 5 and 7 in the rest of the column. This cannot be 5 or 7 then. 5 or 7 is an odd digit, so this must be an even digit. It could be 4, 6, or 8 here, and therefore this must be an odd digit. Cannot be 2 or 4. So since this is odd, this is even. This has to be odd. Of these digits, the only consecutive ones are 9 and 8. So this is 9, this is 8. This must be 7. This is 5. This is 7. This is 5. And so this can't be 5. This can't be 4. It can't be 9 here because of the 9 in the box. Therefore, what digit is this? This has to be 1, which means these cannot be 1. What else do we have here? This digit is even, but it could be 2, 4, 8. This cannot be 6, and it cannot be 8. So this is 2 or 4 here. This digit is consecutive with this. So if it's 3, it could be 2 only. It can't be 4. If it's 5, it can be 6 only. If this is 6, it could be 5 or 7. If this is 7, it could be 6 or 8. So any of those work. This has to be 1, 2, 4, or 9, but this can't be 1 here. What are the remaining digits in column 8? Actually, let's do row 5 first. This has to be 3, 7, or 9. This is 3, 7, or 9. How about column 6, or sorry, row 6. Actually, this can't be 7 here. Row 6 has to be 1, 3, 5, 6, 8. So 1, 3, no 5, 6. So it's 1, 3, 8, 1, 3, 8. This can't be, oh, this 3, 6 pair eliminates 3 from the rest of the column. So this can't be 3, this is 9. This can no longer be 9 then. This can't be 3 either. So this is 1, 3, 5, 6, 8. But 1 cannot be any of these. This can't be 6 or 8 either because of the 6 or 8 in the column. If this is 3, it's consecutive with 4. It cannot be 2 because of the 1, 2 pair in the column. If this is 5, it could be 4, but not 6 because the 6 is in the box. If it's 6, this cannot be with 5 or 7, so this can't be 6. Where is the 6 in row 6 then? It has to be here. If this is 8, it could be with 9. Oops, so this is 4 or 9 here. Remaining digits here. Okay, consecutive digits here can be 1 and 2. But this can't be 1, so this can't be 2. If this were tried to be 2, it can't be 1 or 3 here. 2 and 3 doesn't work. 3 and 4 doesn't work. 4 and 5 could work as long as this is 4 and that's 5. 5, 6 doesn't work. 6, 7 doesn't work. 7, 8 is a possibility as long as this is 7 and this is 8. Okay. Eight cannot be here, 8 cannot be here, so where is the 8 in column 6? It must be one of those two. This can't be 3 because of the 3, 6 pair in the column. So we have a 1, 8, 1, 8 pair in row 6, which eliminates 1 and 8 from the rest of the row, and it eliminates 1, 8 from the rest of the box, so this can't be 7 then. This can no longer be 9, because 9 would only be with 8 to be consecutive, so this is a 4. Cannot be 2 or 6 here, so this is 4, which means this cannot be 4. This is a 3, 5, 3, 5 pair in this box, which eliminates 3 and 5 from the rest of the box, so this can't be 3. This is 7, which makes this a 3. None of these can be 3, therefore this cannot be 2. We have a 5, 6, 7 triplet here. The remaining digits here are 2, 3, and 4, but this can't be 3 because of the 3, 6 pair in the column. Therefore, that leaves, where's 3 in row 4? It must be here. So this is 3. This has to be an 8, 9 pair, and this can't be 9 because of this 9. So this is 8, which makes that a 9. Remaining digits in column 7 are 3, 5, and 7. So this is 3, 5, 7. These are 3, 5, 7, but this can't be 3 because of the 3, 6 pair in the row. Remaining digits in column 9 are 3, 5, 6, and 8, but this can't be 6. Where is the 6 in column 9? It has to be here. This is then 3, 5, and 7. This is 3, 5, or 8. And we don't know which one that is. Okay, this 3 eliminates that 3. So this is a 6, which makes that 3, which makes that 6. So 6 cannot be any of these digits. We have a 5, 7, 5, 7 pair in row 2, which eliminates 5 and 7 in the rest of the row. So the rest of the row must be 1, 2, 4, and 9. This cannot be 9. These can't be 9 because they're 1 or 2 and 2 or 4. Where is the 9 in row 2? It must be here. So this is 1, 2, or 4. This can no longer be 9 because of this 9. We have a 2, 4, 2, 4 pair in column 6, which eliminates 2 and 4 in the rest of the column. And we know 3 has to be one of these two digits because it cannot be any of these 4. And it can't be here. Therefore, this can't be 3. Where is the 3 in column 6? It must be one of these two cells. We also have the possibility for 3, 5, 6, 7, 8. 6 cannot be either of these, but 6 could be here. 6 cannot be here. So this could be 3, 5, 6, 7, 8. 3, 5, 6, 7, 8, but 8 cannot be either of these two cells. This can't be 5 or 7 here because of the 5 or 7 here. Therefore, we have a 3, 6, 3, 6 pair in row 7, which eliminates 3 and 6 from the rest of that row. So this can only be 1, 2, or 9 here. Well, it can't be 1 or 2 because of that 1, 2 in the column, so this is 9, which means this can't be 9. Let's see, what else do we have? Where is 7 in column 1? It can't be consecutive anymore because 7 can only be consecutive with 6, which neither of these can be, or 8. And 8 cannot be here. So 8 would have to be here, which would force 7 to be here, which is not allowed. 7 can't be here because of the 5, 7 pair. 7 therefore has to be here. Remaining digits here, it cannot be 5. Whereas a 5 in column 1, it has to be here. So this is 5, which makes this a 4, which makes that a 2. This 4 eliminates 4 from being here. This can be 1, 2, or 8. We don't know which. This 5 means this can't be 5, and this can't be 5. This can't be 6 anymore, therefore this can't be 5 here. One of these has to be a 7. It's either 6, 7, or it's 7, 8 to be consecutive. So therefore this cannot be 7, and this can't be 7. Neither of these can be 7. We have a 3, 5 pair in this box, which eliminates 3 and 5 in the rest of the box. Therefore, this must be 7, not 9, 7, which makes that a 5. Okay. Remaining digits in row 3. They have to be 1, 2, 3, 7, or 8. Well, it's be 1, 2, cannot be 3, 7. It could be 8, though. This could be 1 or 2, cannot be 3. It could be 7, and it cannot be 8. Remaining digits in column 3 are 1, 4, 8, and 9. They still could actually be all of those. Okay, we have a 1, 2, 4, 8, 9. Actually, we have a 6 here, so that makes this 3. So that makes that easy, which makes that a 6, which makes that a 3. Therefore, this can't be 3. This can't be 5 anymore. Where is the 5 in column 6? It has to be here. So this is 5, which means this can't be 5, this can't be 5. Where's the 5 in this box then? Can't be here, can't be here, can't be the filled in digits, and must be here. So this is 5, which makes this 3, which makes that 5, which makes that 3, which makes that 5. This 7 eliminates that 7, so this is 3, this is 8, and this is 7 left. This cannot be 8. This cannot be 8. We have a 1, 2, 1, 2 pair in column 1, which eliminates 1 and 2 from the rest of the column. Therefore, this is 8. This is 1. These cannot be 1 anymore, and this can't be 1. This has to be 6 or 8, but it can't be 6 because of the 6 in the row. So this is an 8, which makes this 7. This is 6. This can no longer be 6. This 7 eliminates that 7, so this is 3. And this cannot be 7. We have a 1, 2, 1, 2 pair now in row 3, which eliminates 1 and 2 in the rest of the row. Therefore, this can't be 1 or 2. This is 8, and that means this can't be 8. We have a 2, 4, 2, 4 pair in column 2, which eliminates 2 and 4 in the rest of the column, which leaves us 1 and 9 remaining. This is 1 or 9, this is 1 or 9, this cannot be 8. We have a 4, 9, 4, 9 pair in column 3, which eliminates 4 and 9 from the rest of the column, leaving this as an 8. We have a 1, 2, 4, 9 actually, we have a 2, 4 pair in row 8, which eliminates 2 and 4 in the rest of the row. This cannot be 2, so this is 1, this is 2, which makes that a 1. This 1 and the 2, 4 eliminate 1, 2, 4 here, so this must be 9. This 5 eliminates that 5, so it's 7, which makes that a 5. The only digit remaining here has to be 7. We have 1, 2, and 4 remaining here. This cannot be 1, so this is 2 or 4. This then must be a 6. This has to be 1, 2, or 4. And 4 cannot be, has to be one of these two digits here. Actually, we have, 1, 2, 1, 2 pair, which eliminates 1 and 2 from the rest of the row. So this is 4, this is 9, this is 1, this is 2, which makes that a 1, 9, 2, and 4. This 2 eliminates that 2, so this is 4. This has to be 2 left. This 4 eliminates that 4, so it's 2, 4, 2, 4, 1, 2, and 1. And that is cool and good. Yeah, interesting. I've never seen the quartet lines before. Seems like it might be able to, you might be able to use that rule set decently. I don't know. It's a interesting rule set. But I don't know how much run you can have with that. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.